Okay, we're back on. 90 degrees clockwise. What could we do instead? 90 degrees clockwise will take me from one spot to like that same spot in the next quadrant over. Or I could go this much around instead, right? How much is that?
180.
No. No.
270.
270, right? So instead of going 90 degrees clockwise, I'm going to cross that out. I'm going to go 270 counterclockwise. Now we're fixed. Now we can do that, okay? All right, but first things first, our center is at B, so we've got to take 115 and I've got to do undo the B to it, right? 17, negative 1. So we have to subtract 17, add 1 to get him to 0, 0. So now he is at negative 16, positive 16. Okay, you remember the rule for 270?
Negative what?
They flip, but the second one's negative. 270 comes after 90. 90, the first one's negative. 270, the second one's negative. So I'm going to flip them. So 16, negative 16, but then the second one becomes negative, so he becomes positive. Confused? Okay, now what? One more thing. Now I got to do the 17, negative 1 to him.
Subtract 17.
Now we add the 17.
Oh, okay.
Because we subtracted it before. So we add 17 and subtract 1. So 33, comma 15. I think that's what we got. Last period. 33, comma 15. That's what will do it. Okay? Happy with that? Ish? All right. Let's see what we got going on here. All right. Find the coordinates. We are first and foremost translating negative 11, 8, and then we're reflecting across the line y equals 4. Okay, so negative 11, 8. Oh my heavens. All right, this guy, if I go negative 11, 8, negative 11 will make this guy 2, and 8 will make this guy 4. So 2, comma 4 is what he will be. So he's moved there. Okay, this guy, if I go negative 11, 8, he will be at negative 4, comma 5. So negative 4, comma 5 right there. And this guy, if I do negative 11, 8, you see what I'm doing?
Mm-hmm.
Negative 1, comma 0. Negative 1, 0. It's always confusing because it's going by 2's. So this is what he looks like now. Boop. And he's the same shape and same size as what he was before. Y equals 4 is where I'm reflecting him. So he goes like this. Across y equals 4. Okay, so this was S, this was Q, this was R. Okay, we've got to figure out how we're going to flip him over that line. So this guy, because he's above, he's now going to go below. Does that make sense? Okay, so he is like one step above, he's going to be one step below. So this is like Q double prime. These are Q prime, R prime, S prime. So Q double prime, what's Q double prime going to be? Like negative 4, comma something. Where is he at right now?
Negative 4, 3.
Negative 4, 3, I think. Yeah. Yeah. Okay, what about S double prime? Where does he go? He's like on the line already. So where does he go?
Stay there.
He stays there. Yeah. S double prime is going to stay there. So he is at 2, comma 4. Okay, and then that looks like a negative, but it's not. Okay, and R is like 4 units away here, so he's going to be 4 units away here. So he's at like negative 1, comma 8. Did I do that right? So that one is just doing 2 at once, or like one right after the other. You're doing 2 transformations, and then that's it. Okay, good? 12? Okay, use the graph. Which series of transformations will map rectangle ABCD to rectangle A prime, B prime, C prime, D prime? So how do I get from this rectangle to this one? Like there's a couple of things that I would have to do. And we don't have to be very specific.
Negative 3, 3.
Negative 3.
Negative.
Negative 3, negative 3. So move him down here and over here. Okay, so translate him -3, -3. Okay, that'll move him like that, right? So now he's on top of himself, except the points don't match up, because right now this guy will be D. D will be here, C will be here, B will be here, and A will be here. So what do I have to do there?
You
see that?
rotate.
Not rotate him. So I want D to go here, and I want C to go there. And I want A to go there, and I want B to go there. What's that called?
Flip.
A flip. What's a flip called?
I don't know.
What's it called when you flip it? Like this. What's that?
Reflection.
Reflection. Okay, now we have to decide where we're going to reflect him though. I'm going to say, and reflect over. Okay, where do we have to reflect over? Like this middle guy right here. You see that? Like in order to be exactly perfect, I have to put my pole down the middle and like flip it over. Okay, so what's the equation of this guy right here? Is it x equals or y equals?
Y equals.
This is the confusing part. It's x because it's going through the x-axis.
Oh.
Does that make sense? So it's x equals what?
Is it going by one?
I know, that's the hard part. Is it going by ones or is it going by twos? I'm going to say that it's going just by ones, so we're going to call it 1/2. If it doesn't have them labeled, I'm going to assume that they're just going by ones on each block. So x equals 1/2. So that's one thing that we could have done. We could have reflected him to begin with over this line, right? Reflected him to start with and then moved him down. That would be another option. I'm not going to write that down, but that would be another option. So there's a couple different things that you could do to get him to work, okay? 13. Let's do this guy. We are taking 7, -6 and reflecting him y equals x first. Okay, so let's do that real quick. How do you do y equals x? What does that do to him? What's the rule when you're going across the y equals x? That's this guy. 7, -6 is like right here. So there's where we're starting. How do I reflect him across y equals x? Like he'll go over here.
Flip 7 minus.
Yes, so when I flip him, he'll be -6, 7. So the xy just becomes yx. Yep, so -6, 7, he'll be right there, okay? Now, the next thing that I want to do is reflect him across x equals -4. So I got a -4 on the x-axis, and he's going to be, is he going to be vertical or horizontal? X equals -4. I got a -4 on the x-axis. Will be up and down or left and right?
Up and down.
Up and down. Okay, and so this dot right here, if I bump him over, he'll be in this spot. So where will he be now? What will his coordinates be?
-2, 7.
-2, 7, perfect. That's that. Okay, -2, 7. You got it. Okay, all right, 14. I have all the answers written here still from the other class. I need to erase. And we did 20 already, right? Okay, so we got the easy ones left, kind of, after maybe 14. And 15. 15 is kind of a hard one too. Okay, 14. I want to take this pancake and I want to flip him over top of this line, which puts him here, and then I want to flip him over top of this line, which puts him here. What could I have done instead?
Just flip him over. K, J. Like,
Not flipped him.
or split him.
Slid him over. How far do I slide him over? So that's a translation. Translate how much?
13.2.
6.
Oh.
Yeah, good math though. 13.6. Yeah, it's double this amount, 6.8. So if I slide him over double the amount, that will be the same as flipping him and then flipping him again, right? Okay, that's 14. Good, good. What single transformation maps the pancake from P to P double prime? A translation, 13.6 inches. Okay? All right, 15. I don't know. I think these ones are the hard ones, but you guys do really well with them. So we have a 15-sided figure. A 15 gone. Whatever, all the way around, huh? And we're trying to figure out what one of the angle measures of a 15 gone is. Like what one of those guys is. Okay, so how do I figure out what one of those angles is?
15 times 1.
No, not 15 times 180. If it's 15 sides,
How to do this.
if it has 15 sides, then I make triangles out of
It
him.
has 13
He will have 13 triangles, okay? And one triangle is 180, so I take 13 times 180. What does that become? Like 2420.
2,340.
2340. Okay, so there's 2,340 degrees inside of this if I would add all those up together.
It's not a tessellation.
Okay, so now what did you do from there?
Divide by 360.
Nope,
3.
we gotta do one more thing. If 2340 is inside of here, what is each one of these?
Divide by
Divide that by 15. Okay, what's 2340 divided by 15?
156.
156. So each one of these is 156s, 156s, 156s. So if I look at like one intersection, like let's talk about like putting a bunch of these together. Will the 156s add together to make 360? If I take 360 and divide by 156, it's like 2.3 or something. So I would need 2.3 of these objects in order to make 360. So that's not going to work. They're not going to be whole together. So, okay, let's fill in the blank. An interior angle of a regular 15 gone is 156. So a 15 gone will not tessellate the plane. There you go. Okay? Those ones I think might be a little bit hard. If you want to add some stuff like that on your note card, you can. If you got it, you know how to do those. I think you guys are pretty good on those. Then you don't have to. 16. How many lines of symmetry are there in this figure? Let's draw them. I see one here. Boop. Where else? Is there any else?
I couldn't find any.
What about this one?
And the other one.
And the other way.
But doesn't the circles not?
So if I get rid of like this guy and like he's folded in half, turn your head. Yeah, he'll fold exactly in half onto the other one. Does that make sense?
No.
You see it? No?
Because then when the
Like this circle will fold on top of this one. This half circle will fold on top of this one. You see it?
Oh, okay.
You see it?
Yeah.
Yeah? Sometimes it's hard to see. So, how many are there?
3.
1, 2, 3. 3 of them. Good? You see how that works?
Yeah.
Yeah, perfect. Okay. All right, this is a weird question. I don't know. Okay, let's just read this. Here we go. Let's talk about this guy. This is how I interpret this to be said. So it's kind of confusing. It says, Winnie says that all objects with a line of symmetry can be reflected across that line to obtain an identical image of the object. Okay, so like, let's talk about this like triangle here. She says that if I have a line of symmetry here, and I flip this image over top of that line of symmetry, in other words, I do one of these to it, okay? And it will obtain an identical image. Is that true? If I take this line of symmetry and I flip him over top of that line of symmetry, will he be identical to himself?
Yes.
Yes. Okay, so she is correct. Henrico says that if I can reflect, he says the opposite. If you can reflect in a line contained in the original object and obtain an object that's identical to the object that you had to begin with, it has a line of symmetry. So in other words, he is saying, if I have this random line in here and when I flip it over top of that line, it matches up, then this line must be a line of symmetry. Is he true also? Is he correct? Yeah. So who is correct? Winnie is correct, Henrico is correct, both Winnie and Henrico are correct. We said C, okay? Do you remember what it's called when you say something and then you say it backwards? What's it called when you say a statement backwards? Like we did this in like chapter 2. I'm trying to even think of an example. If you live in Blue Hill, then you live in Nebraska. If you live in Nebraska, you live in Blue
What
Hill,
are they called?
right? What was that called? It's the name of a shoe.
Converse?
Converse. It's like saying the converse. You're flipping your statement around. Now, not always is it true, right? If you live in Blue Hill, then you live in Nebraska. That's true. But if you live in Nebraska, you don't necessarily live in Blue Hill, right? But in this case, for this one, when they were saying it forward and then they were saying it backwards, it was in fact true both ways. So we're saying both Winnie and Henrico are correct. Make sense? Clear as mud? Okay. 18, here we go. The flower shown has rotational symmetry with an order of, do you remember what the order stands for?
How many?
How many times can you flip them around? So like that, this petal can go to this spot, 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 can go to this spot. What is the order? 6. Okay, and how many degrees is the magnitude?
360 divided by
360 divided by 6. Do you know what that is?
60.
60, perfect. 60 degrees. Oh, there we have the degree. That's the magnitude. Order, magnitude, not too bad. Okay, last one. 19, we had some debate about this, and Remington was the one that was like, I had to pick on him for a minute because he was really on the struggle bus. Lines of symmetry. Which one has lines of symmetry? Like that I can draw. What?
I.
Now I, so you're talking like right here?
Yeah, like if you.
Like if it goes down the center, right?
Yeah.
Like the word I. Okay, but here's the problem. If you make a line go right here,
Oh wait.
and you flip it that way, the E is going to be backwards.
Oh.
So I is not going to work. These are tricky.
Hot's not gonna work.
Hot's not going to work.
6 isn't.
6 is not going to work. Even if, because you could draw your line like this, right? Horizontally, but if you flip it upside down, then your S is going to go this direction, right? So that's not going to work. What about hoax?
It will. No.
It will not work because the A will be upside down. Okay. Dim, will dim work? The D and the I will, but the M will be upside down. Right? What about code?
Yeah.
Code will work. Yep. He's the same front and back, or top and bottom. What about youth?
No.
No, and this way won't work either, obviously. Decide.
No.
Everything works except the S, right? The S will be upside down. What about exceeded?
Yes.
Yeah,
Yeah.
top and bottom, he's the same. So F and I think is what we got. There was one question maybe on like your quiz that you had where it said like find which ones have 180 degrees that you can rotate in. Like out of the alphabet, out of the capital letters, like which letters can rotate 180 degrees and be on top of themselves. Do you remember that? Like the letter X. I could rotate him around and flip him upside down and he would be the same, right? And there was like 7 of them. S is another one. And Remington was like, what the heck? S doesn't work. Like, yes, boy. Like, S. S. So I took a card and I'm like, Remington, here's your card. This is an S. I'm going to flip it upside down. Is it still an S? And he's like, what the heck? Oh, Remington. And then we said N. And he's like, N does not work. Remington, this is an N. Ready? Is it still an N? He's like, no, that's stupid. You can hear him, right? That's stupid. Okay, X, N, Z was another one, O was another one, H was another one, and I was the 6th one or 7th one. So when you're rotating them, that's how that all works. Okay? So weird stuff like that. And then we did 20, yeah?
Yeah.
Perfect. And you have that written on your note card. Okay. All right. I'm gonna stop there. Goodbye, Aiden.